All right, guys, if you are watching this video, it means I am homesick because I had a little reaction to my second COVID shot. Because I've been hearing some people have been having some body aches and a little fever. So I wanted to make this just in case I wasn't able to be in school. But we can do the same stuff. You guys are watching on your phones, but please use your classmates as a resource. I do not have my TI 84 emulator on the computer I'm working on at home right now. So unfortunately, I can't show you the buttons to hit on the calculator, but I will show you how to do it on Desmos. So if you do have a TI-84 and you want to kind of work on it that way, but you're not sure how, reach out to one of your learning group members, talk to a friend in class, text somebody, or just Google it, and there'll be, I'm sure, some good videos showing you. So first thing, let's look at the homework. I know I asked you to do letters C and D. I asked you to set them up. And if you had a calculator, you could solve it out, but I will show you how to do that. First thing for today, everybody should make sure that they are in degree mode in their calculator. So you're going to hit the mode button and you're going to scroll down and over until you see the word degree. And then you're going to hit enter so that the word degree is darkened, that it's highlighted. All right, not radian. So that's our first step. So for letter C, I went through the whole process like we talked about in the homework. We put a star next to our reference angle. All right. And the reference angle, again, this is a big question people had, is the angle that we know something about. All right. Not counting the right angle, right? The right angle is kind of its own thing. So in this case, the 57 is my reference angle. I know that the hypotenuse is right here. And this side here is opposite from my reference angle. It's the one across the way. So in this case, since we're working with the hypotenuse and the opposite out of our SOHCAHTOA, that means we're using the sine ratio. So again, it's SOHCAHTOA. Sine is the opposite side over the hypotenuse. Cosine is the adjacent side divided by the hypotenuse, and tangent is the opposite over the adjacent. So in this case, I know that my sine of my angle, the sine of 57 degrees, is equal to the opposite side, 10.8, divided by the hypotenuse, which is x. So now we have to do some algebra. Just like these first two questions that I mentioned, the way to get rid of this x in the denominator is to multiply both sides by x. This is where you cannot go onto that autopilot and work too quickly. So looking back at questions A and B, sometimes, and actually I don't have all my work shown here, but sometimes, like for this first one, for example, it's going to come out to be 11 times the tangent of 43 equals A. So right away I have the A by itself and I'm ready to plug this into my calculator. For the one like letter B that I showed you, it became C times the cosine of 40 equals 6. And I had to first divide both sides by the cosine of 40 to get the answer by itself. So there's two different ways you're going to see these questions. Sometimes the answer is going to be by itself right away, and sometimes you're going to have to do that extra step. So in this case, we're going to have to do that extra step because I have x times the sine of 57 equals 10.8 because those x's divide each other out. Now to get the x by itself, the x isn't by itself yet, I have to divide both sides by the sine of 57. All right, so as I'm going through these examples today, at whatever point you feel ready to kind of pause and just try a bunch on your own, you can go ahead and do that and just kind of unpause when you're ready to check my work. So the reason we did that here is because the sine of 57, those divide each other out. And that's my answer, basically. That's what I'm going to type into my calculator. So if you have your own TI-84, literally just make sure you're in degree mode, and you can just plug that right into your calculator. If you don't have a calculator, or if you want to use Desmos, here's my little tutorial. So we're going to go to desmos.com, and I'll link this in the class work for today. You're going to go down to where it says scientific calculator. All right, so we can see right here my sine. Let me highlight it for you here. There we go. We have our sine, cosine, and tangent. So for this problem, to find the answer, we have 10.8 divided by the sine of 57. So I'm just going to type that in. 10.8 divided by sine 57. And again, right here, you can see radian mode, degree mode, radian mode, degree mode. We need to make sure we're in degree. So my answer is 12 point, I forgot what I told you to round to. Let's call it 12.9. So there's my answer. And this next one was very similar. My reference angle is 52. The tangent ratio is opposite over adjacent, so I'm going to multiply both sides by x. Those x's divide each other out, and we're left with x times the tangent of 52 equals 12. So without going on to autopilot, I can't just type in 12 tan 52. I have to think, do I need that last step? And in this case, again, we do. So to get the x by itself, I'm going to divide both sides by the tangent of 52. Those go away. Here's my answer. 12 over tan 52. Back to my calculator. Let's clear all. 12 over tan 52. Boom. Answer about 9.4. All right. So what I want you guys to do, I'm going to pause. I want you to try letter, well, there's no letter next, but I guess we'll call it letter E. I want you to try this one on your own. So see how you do. Please pause. And then if you got it right, that means you're in good shape. If not, text somebody, look at a video, ask a friend in class, rewatch this part of the video, and hopefully after that you'll be feeling good. So I'm going to pause now, and then you should unpause when you're ready to watch my work. Okay, so hopefully you really pause and try this one out honestly. You can see first thing again, I labeled my side. So there's my reference angle. Let's get a nice little star going here. There's my reference angle. I labeled the three sides. My hypotenuse is the 7. My opposite is over here. I put an X through it because I'm not using it. I don't know anything about it. I don't want to know anything about it. And my adjacent is the side right here that we're looking for. So we go to our SOHCAHTOA. The one that uses the adjacent and the hypotenuse is cosine. So the ratio I set up is that the cosine of the angle, it's always the cosine sine tangent of the angle, equals the adjacent side divided by the hypotenuse. To get rid of our fraction, I'm going to multiply both sides by the denominator. That gets my 7s here to divide out. And I'm left with x equals 7 times cosine of 36. This is one of those examples where we don't have to do the extra step. So looking back at my calculator, that's all I have to type in. You don't have to type in the times sign. You don't have to do that on your calculator either. 7 times the cosine of 36 is 5.66. I rounded it again to like 5.7. So that's what your Delta Math skill check is going to be on today. Sorry, let me say it again. Your Delta Math practice set. It's not a skill check. You're not getting graded on this. There's 5 questions like this that you have to do. You have to get 5 points. Each question's worth a point. If you get one wrong, you lose a point. So you can go backwards, but you have to get to that 5 points. You have an unlimited number of questions to get there. So now we're also going to learn how to find a missing angle. So looking at these questions, you don't have to write this down, but I would like you to pause for a minute and see if you can come up with what these angle measures could be. So think back to that homework video we did a few nights ago. Think back to what you know about this triangle on the right-hand side. What could those angle measures be? So I'll give you a second to brainstorm. All right, so please pause if you haven't. All right, so this trigonometry stuff works both ways. If I know what the angle is, then I automatically know what the ratio of the sides are. That's what we did on the last page. So if I know what the angle is, then I know what relationship the sides have to be in. But we can also do it the other way around. If I know the relationship of the sides, I know what this angle has to be to create this relationship. So what this first question is, this is exactly like the homework we did on when we did the GeoGebra investigation, where you guys were playing around with the size of the triangles. Whenever the opposite is exactly half of the hypotenuse, this angle has to be a 30-degree angle. That's the only way that relationship works. So I know that for sure. I know that's a 30-degree angle. Looking at this next one, I have two sides that are equal. I can actually do a couple different things here. I can find, this is an isosceles triangle. So I know that this angle, for it to be isosceles, has to be 45 degrees. That's the only way there's two equal sides like this. I could also find the hypotenuse here. I could do a squared plus b squared equals c squared, and we could solve it out that way. So 3 squared is 9, plus another 9 is 18 equals c squared. This is an important step. We're going to talk about this in a second. To get the c by itself, I have to do the inverse operation. So the inverse of a square is a square root. So I have c equals the square root of 18. And we even can go farther with this. We worked on this one day in class. I can break that 18 up into the square root of 9 times the square root of 2. Remember, we always want to look for the biggest perfect square. If you forgot this, go back to, I think it's page 2 of your notes to remind yourself if you're not sure what I'm doing here. But page 2 of your notes is where we worked on simplifying radicals. The square root of 9 is 3. And then the square root of 2 we can't do anything else with. So that's how I could find the measure of that hypotenuse. All right, but the great thing is I can find this angle anytime I know the relationship of the two sides. So it's very, very, very similar to what we did on this last page. In fact, this is a little bit easier even. The last page, we had to do a little bit more algebra. So I set up my relationship, and then I had to work a little bit to solve for this missing variable here. It's a little bit easier when we're finding the missing angle. So looking at this next page, little refresher, that theta symbol, you're going to see that on some examples. That theta basically means a missing angle. So you'll see this symbol when you're looking for a missing angle a lot of times. But we're going to do the same thing. We're still going to use our SOHCAHTOA. So for letter A, let's go through that process. There's my reference angle. So I'm going to put a star there. That's the one we're looking for. That's my reference angle. Hypotenuse is the longest side across from the right angle. The opposite is the one across from my reference angle. And the adjacent is the one that's left. It's the one next to my reference angle. So let's see. Looks like, again, I'm not using my hypotenuse, so I'm going to cross that one out. So we have a cosine. We have the adjacent and the hypotenuse. So I know the cosine, here's where we got to be careful. It's not the cosine of 52. It's not the cosine of 56. It's the cosine of my angle. So I'm going to put that theta there. You could also put an x. If you wanted to just do cosine of x, that's fine as well. Let's keep it as an x for now because we're more used to seeing that. So I know the cosine of x, the cosine of my unknown angle, equals the adjacent side divided by the hypotenuse. So really what that's saying is that the cosine of some angle has to give me this relationship of 52 over 56. So now we just need to figure out what this angle is. So a lot like what I did on the last page, to undo a squared, we have to do the square root. To undo the cosine, we have to do something that's called the inverse cosine. So that inverse cosine, it looks like a cosine to the -1 power. That inverse cosine undoes this cosine so that all we're left with is the x here. But if I'm going to do the inverse cosine to one side, I also have to do the inverse cosine to my other side. So I have the inverse cosine of 52 over 56. So really all we're doing is just taking the inverse. We're undoing this relationship to find the angle that gives us that relationship. So if you're on your TI-84, if you look right above your cosine button, you'll see it says cos -1. So all you have to do is hit second cosine, and that will give you this cosine inverse button, and then type in 52/56, and that will give you the answer. I'll show you what it looks like on the Desmos. So I'm going to clear this all out again. Now, the only thing is it's not here under our regular page. We have to go to function, and there we go. So I hit cosine inverse right here, and then I do 52/56, and bingo, there's the angle. So it tells us that about a 22-degree angle gives us this relationship of the sides in this example. So about a 22-degree angle. All right, I'm going to pause again. Why don't you guys try letters B and how about D? Why don't you guys do B and D? Just get them set up. If you get stuck at the end, I'll show you how to walk through the rest of it. But see what you can get done on letters B and D, and then I'll show you what I have in a minute when we get back together. Okay. So reference angle is my theta. In this case, we're looking for the opposite and the hypotenuse relationship. So SOHCAHTOA. This is the sine relationship. Sine is the opposite over the hypotenuse. And again, it's different from the last page. It's not the sine of a number here. It's not the sine of 51. It's not the sine of 55. It's always the sine of the angle that we're working with. But in this case, we don't know the angle. So it's the sine of theta. I use theta this time. The sine of theta equals the opposite side divided by the hypotenuse. So you can see, I'm gonna take a little shortcut. I'm not gonna show this every time. You don't have to. Why did my magic pen work there? There we go. So anyway, hopefully you got the idea. I'm not going to use this every time. Now I can't move it. Whatever. I'm just going to skip this next step. I'm not going to do this. There we go. Yeah, there we go. So I'm not going to show the inverse kind of the cosine. You can kind of skip that step. So I know I'm going to be taking the inverse. So really to find theta, I just need to type in the inverse sine of 51/55. All right, be really, really aware. The biggest mistake here is people always want to go like this and do times 55 on both sides. You don't need to. We're almost done right at this first step. All we have left to do is type that inverse into our calculator. All right. And then same thing for letter D. There's my reference angle at B. So there's my angle I'm looking for. That means B is my reference angle. I don't have anything about my hypotenuse. I know the opposite is the one over here. Be really careful. A lot of times people just look at this and automatically assume that first angle they see is the reference angle. But in this case, this is my reference angle here. So the opposite is the 7.7. The adjacent is the 14. So opposite and adjacent is my tangent ratio. So I know the tangent of my angle, the tangent of theta, equals the opposite over the adjacent. To get the angle by itself, I need to do the inverse to both sides. Now I can go right into my calculator, and I get theta equals 29 degrees. All right, so you're also going to have 5 of these questions on your Delta Math today. All right, so for this, same thing, you have to get 5 points. If you get one right, you get a point. If you get one wrong, you lose a point. So you have as many opportunities as you need to get those 5 points. But this is the skill you need to get really good at for next class. There will be a graded Delta Math couple of questions on these 2 types of problems next class. All right, so be ready for that. If you need help with anything, let me know. Talk to a learning group member. But that's it, and I will see you guys next time in class. Bye.